This video is to show you how to do the red blood cell osmolarity lab graphs on a Macintosh. So I downloaded the file from Canvas, and you should actually download it to your desktop and use the full version of Excel. The online version of Excel is very limited in what it can do. And for this, you're going to be graphing the means of the permeable and impermeable solutes. So first thing we need to do is find the means. So I gave you a column for the mean. To calculate the mean, you just highlight those two boxes, go to Formulas, over here with AutoSum, you click on that little triangle, Average. Now that took a lot of time. So to speed things up, I'm going to copy that box, Control C, then go highlight those boxes, Control V, Control V, Control V. As long as there's a line flashing around here, you can paste that formula into all of these boxes. And that is a real time saver. So next we have to figure out which are the permeable solutes, which are the impermeable solutes. A permeable solute is going to basically not change the volume of the red blood cell. So the percent transmittance are going to stay pretty much the same. So ethanol, 98, 103, 100, 99, 103, 101. That means ethanol is a very permeable solute. Urea, 102, 94 is a bit low. It shouldn't be that low. 100, these are also low. We get a frowny face U. But this should be all about permeable. And I say the border, it should be within 6 or 7% of the control. So our third one, methyl alcohol, 99, 106, that's within 7% of the control. 100, 102, 101. So these are our three permeable solutes, methanol, ethanol, and urea. And we know that because the percent control for the transmittance stayed around 100%. Again, it's within 7 or 8% of the control. Or if we look at our impermeable solutes, we have glucose here. Impermeable, we have it going as low as 64% of the control. So that means it was shrinking and shrinking and shrinking, and as high as 188% of the control. And that means it was growing and growing. So this one, there's a lot of fluctuation compared to this. So that tells me it is impermeable. And the cell is either shrinking in the hypertonic or it was swelling in the hypotonic solutions. Same thing for sodium chloride. We have it shrinking in the hypertonic solutions, and we have it swelling in the hypotonic solutions. So again, these are hypotonic. They have less solute outside than in. These are hypertonic with more solute outside than in. And then potassium chloride, way big fluctuation. Now glycerol is interesting. It's allegedly permeable, but for this experiment in the last few semesters, it hasn't been permeable. And it's a big clunky molecule. I bet you if we let it sit for about 10 minutes, it would act permeable. So I'm going to actually move glycerol for a second. Control C, Control V, Control C, Control C, Control V. And I'm putting all of my permeable ones down here. You don't have to do that. So I have all my permeable ones up here, all my impermeable ones down here, just to make my life easier. So I need to make two line graphs. The first is of my 4 impermeable solutes because they have lots of fluctuation. It shrinks in the hypertonic, swells in the hypotonic. Then my 3 permeable ones, there's not much variation. So I'm going to select my first data set, glucose, and I am going to go to Insert, Line Graph, and I like it with markers. So here's my percent of original. So we could see we have a lot of fluctuation there. Unfortunately, I don't have my x-axis. So to do this, I'm going to do Command click, which is right click on the PC. And that gives me this menu. So again, I went to the middle of my chart. I did Command click, which is right click on a PC. I'm going to do Select Data. And this screen pops up. I'm going to want to label my horizontal or my x-axis. So I'm going to click on that. I'm going to highlight my concentrations. And I am going to then click Enter. And I'm going to call Series 1 glucose. and then click OK. So I have, here's my concentrations. Here is my percent of original. So that's my control. It's 100%. So it went down in hypertonic, up in hypotonic. Now I need to add my other impermeable ones. So I am going to go right click on the PC, which is command click on the Macintosh. Select data. I want to add a data set. So I'm going to hit the plus, and it's going to ask me to choose a range. I'm going to move these boxes out of the way. I am going to then click add. I'm going to call it sodium chloride. And then for these values, I like to get rid of that whole thing because I end up hitting some weird key you don't have. I'm going to click on that, or since I have clicked on that, and then the means for sodium chloride. And I am going to click OK. Sodium chloride is added to my graph. I am then going to repeat that for the glycerol and the potassium chloride. So command click, select data, add glycerol. Oops, I put that in the wrong place. That one is glycerol. I'm going to delete that and then highlight my glycerol means. Click OK. And then lastly, for the potassium chloride, select data, add potassium chloride. I am then going to click on these means, click OK. And again, for all of these, I have a lot of variation. Here it goes from 50 to 250. So that tells me it's an impermeable solute, lots of variation. Now I need to have axes here. I need a title. So quick layout, I find one that has all my axes and a title. I'm going to pick that one. Chart title is my impermeable solutes. This is percent of control. This one is constant in milliosmoles. And I will then repeat the same for the permeable solutes, and then copy and paste this into Word. So to start the permeable solutes, again, you're going to go to Insert. You're going to highlight the means. I'm going to start with this one because it actually is a well-behaved permeable one. Highlight those, Insert, Line Graph. Now, this looks weird until you look at this. Oh, that's 105%. This is 95%. So this is actually just fluctuating on 100%. So if we adjust these axes, we can actually see pretty much a straight line. But first, let's put our horizontal. So command click, or right click, or option click, or control. Select data. The name is ethanol, and our horizontal axis. And notice I only have to change the horizontal axis once. So, okay. Then I'm going to add, select data. Again, that menu comes up when you do command click or you do right click if you have two mouse buttons. I will add, this one will be methanol. And let's see if I can find the data. I will highlight the data. Let me highlight the data. Hold on a second. So I'm going to select my data. Click OK. And I would do the same with the urea over here. Now I want to format my axes because this one It looks like there's variation, but look at the scale of this graph, the first graph, compared to the second graph. The scale here goes from 0 to 250. This goes from 98 to 106. So let's make the scale a little bit smaller. I'm going to, again, command click, let's right click on a PC, select, oops, not select data. I'm going to click over here now, click on Format Axis, and a box comes up on the right-hand side of your screen. So what I'm going to want to do is, oops, vanished again, Format Axis, this box comes up. I want to make it, let's do 80 and 120. So see here, when I do that, it's a lot flatter line compared to this. Or if I actually match the axes from that one, let's do 50 and 250. See, I have basically a flat line compared to it is going up. So because there's no variation, that tells me it is impermeable. Now again, we need to label the axes and we need a title. So I come back over here, quick layout. I like this one because it has all 4 things I need on it. And title. Osmolarity or concentration. And here we have percent of control. And you should also have urea on here. So let's put urea on, command, select data, add urea. I'm then going to come over here, highlight them. Okay, so I have them. So see, this is telling me these are permeable because it's not very much variation. These are impermeable. So thank you.